Okay, Bismillahirrahmanirrahim. Assalamualaikum class. So now let's move to the second part of your chapter 3. In the previous video, you learned about mesh analysis where you have a loop, right? So let's say you apply here imaginary current I1 and I2 and then you have the KVL equation. And you also learned about the super mesh. What is super mesh? Is the current source in between of two meshes. Okay. So now we move to the second type of method of analysis that is called nodal. So again, this chapter is quite having a long steps, and I would like to remind you again, time, patience, and do it step by step, slowly. So once you expert with the methods, then you can do it fast. Okay. So same with the mesh, you have two cases. So if you're talking about mesh, you are looking at the current source, right? So if this current source exists in between two mesh, you call that one a super mesh. But for your nodal, we are looking at a voltage source. So there are two cases. One is the voltage source at the reference node to the non-reference, and another one is the voltage source connected between two non-reference node. So what does that mean by this reference and non-reference node? Now let's go to the network terminology. Okay. So node, what is node? Node is when you have two branch and then the interconnection between the first and the second branch we call nodes. So let's say we have another branch here. So let's compare these two. So 1, 2, this is node A and this is node B. Okay. In these circuits, we have what we call node B, and in this circuit, we have node A. What is essential node? Essential node means it has 3 or more branch. So let's say here in node A, it only connect with 2 branch. We didn't call this one essential node. So you always see like this. So this is element 1 and 2. Here also we call node, right? But this one is not essential node. What is essential nodes? It connect between 3 or more branch. So let's say here we have 1, 2, and 3 branch. So we can call node B as essential nodes. So how you are going to make node A essentials? So you're going to extend. Let's say this is 1, 2, and then here you connect to, let's say 3, and then here you connect to 4. So it means it's connect to 4 branch. So we can call here essential nodes. Okay. So now let's recap. How many branch do we have here? 1, 2, 3, 4, 5. 5. How many nodes we have here? So this will be node 1. The whole here, there is no element, right? So become node 1. Here is node 2. And the below one here is node 3. Now, there is another term, essential node. So, what is essential node? Is the node that is having more than 3 branch. So, if you look at this node 1, it connect to branch 1, branch 2, and branch 3. So, we can call this essential node. How about here? Branch 1, branch 2, and branch 3. This one is also essential node. Okay. So, and here also it having it only have only 2, right? So we have 2 branch. How about the below one? We call here reference node. Okay. Okay. Now look at this concept again. Now we would like to differentiate what is the meaning of reference and non-reference node, because this one determine which cases that you're going to solve using nodal analysis. So when talking about reference, anything that is connected to the ground, we call that one reference. So I repeat, anything that is connecting to the ground, we call reference node. So in this circuit, we have how many nodes? 1 node, 2 nodes, and the below one is 3 node. The one that is a reference node is node number 3 here, the below one here. Okay, how about the non-reference node? Is node number 1 and number 2. So it asks here how many. So number of essential node we have 1, 2, and 3. So we have 3 essential nodes. How many reference node? 1 and 2. 2 reference node. How many reference node? So this one is wrong actually. How many reference node? We have only 1 reference node. How many non-reference node? We have 2 non-reference node. Okay, so it depends on your cases just now. So if you look at here, case number 1, voltage source at the reference node to the non-reference node. So reference means what? Reference means the one that is connecting to the ground. So means, let's say you have a node here, right? And then a node here. So if the voltage source is connecting to, so this is a non-reference node to the reference, this is case 1. Okay, how about case 2 here? If your voltage source is connecting to, here is a non-reference node, here also a non-reference node. This is case number 2. Okay, so that's how you're going to see which one is reference node, the one that is connecting to the ground, which one is a non-reference node. This is non-reference node 1 and this is non-reference node 2. Okay, sorry for the mistake here. Okay, now nodal analysis. This is just another way. The one that you solve with a mesh is the first way, and how you, from the same circuit you also can use nodal analysis. So if you look at the mesh you use KVL, right? But for the nodal you use the concept of KCL. Okay, so it usually to solve for the node voltage, any node voltage, usually the essential nodes, and all voltage has a common reference point, the one that is referred to the ground. Because there are several steps here. So the first one is select node that is a reference node. So look at the nodes that is connecting to the ground, that is a reference node. Okay, and then assign the node, the essential node, with V1 or V2 or VT. What is essential node? The node that is connected to more than 3 branch. Okay. Last one is apply KCL and then solve it simultaneously. Okay. So when you try to solve for nodal analysis, so KCL is applied to each n-1 non-reference node. So what does that mean? So when you have here, let's say there's a node and this is another node and this is another node. Let's say this is the circuit, right? So which one is the essential node? So you name here V1, V2. Which one is the reference node? Is this one. This is a reference node. This one is a non-reference and non-reference. So how you're going to solve this one? So let's say you are going to find the current across here, I, right? So now what is the current across I here? So you need to use Ohm's law. Ohm's law says I is equal V over R, right? So looking at the direction, usually the current will flow from the high potential to the low potential. So what is the high potential? V1. What is the low potential? V2 divided by R. So in nodal, you need to do the KCL. Remember, you need to having the direction here KCL. after you having the KCL equation, you need to identify what is the I based on the voltage. So you need to maintain this concept. V high, what is V high? From the current, here is always here V high, and then here is V low, depend on the direction. So here is V high, here is V low. Let's say the current flowing here, right? And then you have R. So V high minus V low over R. Okay. So this is the steps. Choose a reference, assign a node, KCL, and then try to solve. Okay, so let's try to solve example 9. Okay, first, let's identify what is the reference ground. So we have here, down here is the reference ground. Okay, so where is the essential node? So the hole here is, you can name here V1. And then here is V2. Okay, so let me erase a bit. Okay, 1 minute. Okay, so this is V1, this is V2. Okay, so these are the essential node that you need to identify. So in Nodal, we only use essential node for you to have the equation. Next, you need to apply KCL. So where is the KCL? So now, in nodal analysis, when you apply KCL, I always recommend you to make all the current flowing out. So means all the current leave is equal to 0. So I always make like this. Let's say this is I1, this is I2, this is I3. Okay, so by KCL, at V1, what is the equation of the KCL? I1 plus I2 plus I3 will be equal to 0. Okay? Okay. So, when you have two essential nodes, so how many essential nodes? Two essential nodes means you are going to have two equations. So, this will be equation number 1. So, what is the equation number 2? KCL at second essential node. So again, you're going to make it, everything is leaving. So this becomes I4, I5, I6. So I4 plus I5 plus I6 is equal to 0. So this means all the current leaving will be equal to 0. So now let's try to solve number 1. Now, use the concept I equal V high minus V low over R. So what is I1 here? So this is Ohm's law, right? But you don't have any resistance at I1. You only have 1 ampere. Since the current direction is opposite, so you can have here minus 1. Okay? Okay, next. Now look at I2. I2 is V high. What is the V high here? The arrow is pointing down, right? So V1 minus 0 over 2 plus. Now look at I3. What is the V high? Look at the arrow. V1 minus V2 divided by 6 equal to 0. Okay. Now move to I4. I4 is the pink one. Okay, now your focus now is at node 2. At node 2, what is I4? So since the arrow is like this, right? I4, what is the V high here? V2. V low here is V1. So we come here V2 minus V1 over I4 over 6 plus I5 V2 minus 0 over 7. And then the last one is plus 4 is equal to 0. So this is how you're going to solve the equation. Okay, so once you get this equation, you just solve it by removing the denominator by multiplying by 6, and then you got equation number 1 here. Same here, equation number 2, and use your calculator. You will got V1 equal minus 2 volt. V2 is equal minus 14 volt. So this is how you solve for the nodal analysis. Okay, thank you.